Ah, I see. Hello! Oh, it's kind of dark. Let me change that up a little bit. Turn on this light. Whoop. All right, there we go. There we go. 30 degrees in Azerbaijan. I believe it. It's nice though. At least things are good out there in terms of the weather. You're from? Oh, you're living in Dubai. Okay. My uncle lived in Dubai for a while, so before it became like mega rich though. Look at this! Look at this! Look at this! Oh my gosh! Holy smokes! I can't believe it! I cannot believe it. We're here, we're back. Oh my goodness. Hello, 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 everybody. Hopefully, we'll have some people start to trickle in here. Hopefully. You know, Aiken, let me ask you here. What do you think I should do in terms of apart from a math stream? No? Go ahead and here. Okay, that's fair. Not maths related? Yeah, yeah, yeah. Okay, Among Us or Football Manager? Yeah, of course, primarily most of my live streams are going to be maths related, of course, of some variety, but they have to be focused on the classes that I teach. But yeah, I think that's pretty solid. You think some of the other think some of the other hashtaggers would do like an Among Us stream with me? I don't know. Usually it's pretty late, so but if I do it early enough, then maybe I would just have to set it up behind the scenes a little bit. But oh, really? You play Among Us with me, Tom? Wow, thanks, man. I really appreciate that. That's really cool. So if I set it up at the proper time though, like if I set it up at like this time or something like that. Okay, Shari's gonna do Among Us later. Yeah, I could totally get behind that. It's just a matter of if they're not broadcasting or anything like that, we could have some fun just doing some random streams and whatnot. So the only thing I'd have to do is just set it up on my end. So yeah, you're down to playing it right now if we get enough. Yeah, yeah, yeah. Of course. Again, anything that I do will have to be a separate stream from that of my classes because they take priority first. So, but obviously I'm winding down to the end of the semester here. So, uh, doing some odd end streaming there wouldn't be so bad. Especially having fun with you guys would be pretty enjoyable. You guys have a you guys are pretty you guys have a wonderful personalities. So I love hanging with you guys. It's really fun. Well, right now I'm going to be conducting class, so this is pretty much class time unless nobody else from my class comes. I said these 2 days would be review, but I don't know what they're going to be doing here. Just leave the same team for the whole year. I'd have to look more in depth about how to pick that. Yeah, I still got to do my day job. It's kind of important there. My day job's is very important. That's the fun part of my job. That's the fun part of my life. Hey, is doing the work. Yes. Education first, and then comes the fun part. I was playing a little bit of Cyberpunk actually this morning and yesterday. So Fantasy Premier League, should you do it full? That would be pretty fun actually. You know, Aiken. I don't know if you've seen this website or not, but I can show you here since I don't see anybody coming in here just yet. Let me go ahead and show this off to you. You guys get me like, hey, I believe that. I totally believe that. Let's see if it's under this. Oh. All right, there we go. So what I got here is Gold Mash, my man. How are you, dude? Are you doing good? Because I'm doing good now that you're here. I'm doing even better. I'm going to show the case this on the screen here. I think you guys will be pretty interested in this website as well. Let's go to the main screen here. All right, so if you have never been to this website here, this talks about in-depth statistics here and tracks many different leagues from all across Europe. I'll put a link in the chat here. So this is Football Reference. This is footballreference.com. Okay. So basically, this will allow you to look at matches. This will allow you to look at, let's say I want to look at clubs. Let's say we go to the Prem. All right. So let's go to the Prem here. And I say, hey, you know what? Manchester United hasn't done very well at all, recently. But let's say I wanted to look more in depth into Manchester United and why they're having such a hard time. So I click on Manchester United, and here is where they compile those statistics that you hear about very often. Not only, of course, their performances, because everybody's heard about goals and assists and whatnot here, but goals per 90 minutes, and more importantly, the expected amount of goals, XG, as you probably have heard here. Typically, this is run by Opta or another third-party company. I think Opta is running with the Premier League this year. That's what I've been kind of looking into, just like how do I get XG as well? That'd be so cool to find out by hand. But anyway, they use computer modeling and the like to determine probabilities and whatnot in certain situations, and they've compiled an XG here. In XG here, he says, okay, if I were to look at who our star players are going to be, the higher the expected goals are going to be from a single individual player, the better that player is going to be. So, and how much of a value that player is to the team. Now, if we take a look here at, let's say, Bruno Fernandes, Bruno Fernandes has had, X points for FPL, absolutely. If I look at Bruno Fernandes, Fernandes has had an outstanding year. Okay, you top 7,000 out of 8 million, absolutely. See, people got to look at these small little statistics because then you can determine who the best player is going to be on the pitch at any given time. Who's going to create chances? Fernandes created a lot of chances last week. Wonderful midfielder for Manchester United, absolutely 100%. Cavani's been very good ever since he got the transfer over. So I'm very pleased to see Cavani actually flourishing. Yeah, non-pen, of course. Of course, you got to look at non-pen. So even a 0.56 though is still very good. You can see Cavani's done really well per 90 minutes. Now I totally understand that. Take away the 5 and you still have the non-pen of 1.9. 1.9 is still pretty outstanding. You can't lie. If you take a look here at non-pen, outside of Rashford, of course, your main striker, you can you'll actually see here that Fernandes is still up there. NFL and NBA, yes, there are NFL and NBA websites for references, so you can actually go ahead and take a look at those as well. and you can actually compare stats for all the players depending on which one you want to go with. So the Premier League's not the only league that they cover here. Of course, you can talk about the Ligue 1, La Liga, Serie A, okay, the Eredivisie. All right, so Bundesliga, of course, MLS. All right, so you can look through a lot of these things. There's baseballreference.com and stuff like that. Just showing off this website here, Yvonne. Yes, of course we're going to be doing class here. Naturally, that's definitely true. Of course your class takes priority over everything else. But no, nothing to be sorry about. I think that's perfect. No, this is your class. This is your time. So I don't have a problem with you asking that question at all. Okay. Let me go ahead and ask you this question though. Actually, let me go ahead and do the intro here. I'm gonna need to do that at some point. Just people were running a little bit late, so. Okay, let's get started today. Welcome back to Thursday, end of the week time today. So today, just to give it a reminder here. Yeah, right. Definitely worth looking at. Definitely worth looking at. Um, so I see Maricela, I see Yvonne here in the chat. I don't know who else here is in the chat, but um, uh, for you guys here today in O90, today is going to be talking about review here for any mathematical concepts that you'd like me to go over, any particular problems that you'd like me to go over. I will certainly go over those for you. Again, please take ample time here for the Chapter 9 test, all the homework, and the final exam. Remember, that is 100 questions. Again, we did talk about that last time about why that was the case. But again, make sure you give yourself ample time of which to finish that, and that's due by the end next week again by Thursday. So again, just don't forget to finish those. Now, let me go ahead and ask you here, Yvonne and Maricela. Um, can I go over earlier chapters? Yes, it just depends which chapter you would like me to go over, Maricela. So there's a lot of content there, so there's a lot of earlier sections. I don't know which one in particular you would like me to go over here, first and foremost. So why don't you tell me about which concept you'd like me to go over in particular, and I'll be happy to do some examples for that. It could be over fractions, it could be over decimals, it could be over percentages, it could be over, heck, even sign numbers. Okay, we just talked about add, subtract, multiply, and divide in order of operations and stuff like that. We worked with word problems before. So there's a lot of host of different things that we did talk about earlier. I want you to let me know about which one you feel is a little bit more important. Any help with decimals, sign numbers, and percentages? Okay, that's absolutely fair. Let's go ahead and talk about those here first and foremost. Okay, so I'm going to go over a brief synopsis here, but again, about each of those topics here. So again, just hopefully today here for you, Maricela, will give you a little bit of a brush up here on all of those guys. All right, in some capacity. All right. So first, let's talk about the first thing that we'll talk about here is going to talk about decimals. All right. Okay. Now, the one thing that we have to understand about decimals is that for decimals here specifically, adding and subtracting by itself is not too hard. Okay, so let's talk about add and subtract first and foremost. So if we talk about adding and subtracting decimals here, adding and subtracting decimals is not too tough. The key here for this one here, for adding and subtracting here, is just to line up the decimal points. All right, so that's all you really need to do here is just line up the decimal points and then go ahead and add or subtract. So for example here, if we had, say, 3.672, and let's say I subtracted that. Let's say I subtracted by 1.89. Notice that I lined up the decimal points here appropriately. And I could add a 0 here for any blanks that I have. And I could just go ahead and just do straight subtraction here using our normal subtraction rules that we had from last time. So in this case here, let's say we have 7 and 9. We have to borrow 1 from here, make that a 5. So this becomes 17. 17 minus 9 is 8. All right, here we have 5 and 8. We're going to borrow 1 from here. That'll be a 2. So this becomes 15. And so here we have 15 minus 8. All right, which is going to be 7. Bring that decimal straight down. We have 2 minus 1, which is 1. Okay, so there's add and subtract there. Fairly straightforward, no problem. Okay, I think that's, of course, the easiest of the easies. But of course, let's look at the other operations here that hopefully can be helpful for you as well, Maricela. All right, let's look at the next one here, multiplication. So if we multiply here, let's talk about how multiplying works. What's the key to multiplication? Well, the key to multiplication is fairly easy. The key is we have to add up the number of decimal places and move that same amount to the left after multiplying. Okay, so that's the key here for multiplication. Now, let me go ahead and make this smaller here because this is pretty large. I need to make this super big. There we go. Better. Okay. Okay. All right, so what does that mean here in this case? What does that mean here in this case? Well, let's take a good look at this. All right, here. Okay, so if we talk about multiplication here into some effect, okay, then let's say I'm multiplying two numbers here. Let's say it's 2.37, and let's multiply that by 0.129. Okay, so I'm just making up two numbers here. There you go. The first thing that we have to do is add up the number of decimal places. So we have to figure out how many decimal places we have in each number. So in this first number here, we have 2 decimal places. Again, because we have 3 and the 7 here next to the decimal point. Then we have 0.129, and that's going to reflect 3 decimal places. Okay, so with 2 decimal places, 3 decimal places, we're going to have to move to the left 5 decimal places after everything is said and done. For us to go ahead and multiply these two together, we're just going to ignore that the decimal here exists, and we're just going to take the numbers straight up. We're going to take 237, and we'll multiply that by 129. And we're going to first figure out what this is. And after we get this answer here, then we're going to move 5 decimal places to the left to get our final result here for this answer. So let's see what we get. So we get 7 times 9, which is 63. Okay, so carry the 6 here. All right, 9 times 3 is 27. 27 plus 6 is 33. That's fine. 3. 9 times 2 is 18. 18 plus 3 is 21. Go ahead and cross out here because 1 to the left. 2 times 7 is 14. Carry the 1. 3 times 2, 6 plus 1 is 7. And 2 times 2 is 4. So that's fine. We'll cross out 2 more times here. 1 times 7 is 7. 1 times 3 is 3. And 1 times 2 is 2. We'll go ahead and add these together here. We're going to get 3, 7. 7, 7, and 1 is 15. Carry the 1. 4 is 2, 6. 6 plus 3 plus 1 is 10. We'll carry the 1 here, so we get 3. So, this is what we have here so far. Now, all we have to do is move 5 decimal places to the left, because that's how many decimal places that we had found here from before. So here, let's move 5 decimal places to the left. We move 1, 2, 3, 4, and 5. And so in this case here, our final answer is going to be 0.30573. And there you go. I'm just doing decimals in general there, Yvonne. So I don't really have a section that I'm doing. I'm just kind of doing random stuff, as was asked from earlier sections. So just making sure here. So okay. Okay, great. All right, so that's how we do multiplication for decimals. Let's go ahead and talk about division of decimals. Okay, so a lot of what I'm talking about here is just overview for that. So let's talk about division. Uh, yeah, actually we can do one more. Yeah, that's fine. Um, Yep. All right, so if we do one more multiplication here, let's say again I have say I have say I have 221.1. Let's go 21.7. Sorry, 21.7 times uh 0.486. Sure, we'll go with that. All right, so if you were to multiply these together, this first one here would have 1 decimal place. This next one here would have 3 decimal places. Okay. And here in this case, we add these together here, we're going to move 4 decimal places. So here, all we're going to do is we're going to take, ignoring the decimals here, we'll take 217 times 486. We're just going to do that out here first and foremost. 6 times 7 is 42, carry the 4. 6 times 1 is 6, plus 4 is 10, carry the 1. 6 times 2 is 12, plus 1 is 13. X that out. 8 times 7 is 56. Carry the 5. 8 times 1 is 8, plus 5 is 13. Carry the 1. 8 times 2 is 16, plus 1 is 17. All right, cross out twice. Next we do the 4. 4 times 7 is 28. Carry the 2. 4 times 1 is 4, plus 2 is 6. All right, and 4 times 2 is 8. So if we go ahead and add these together here, we get 2, we get 6, 3, 3, and 8 is going to be 14. Carry the 1. 1 and 2 and 7 is 9. 9 plus 6 is 15. I put another 1 here and we get 10. Now again, all we have to do is just move 4 decimal places over to the left. So let's do that. So here we're going to get 1, 2, 3, and 4. So our final answer here is 10.5462. And there we go. Got it. Nice. Any questions about that? Hopefully that'll clear up the multiplication part. All right, I'm going to go straight into division here, because I do want to do an example of that. Now, if we do the division here, let's say we have a division here of, let's go with 31.5. Let's say we'll divide that by 0.23. Okay, let's say we have that. Let's say we're dividing two things just like so. Okay, so what's the key here for division? All right, if we're dividing two numbers like that, is basically the key here in this case is going to be down. All right. The key here is to basically move the number of decimal places on the outside to make a whole number, and do the same on the inside as well. Okay? And do the same number of decimal places. And actually, I should say it like this, and move the same number of decimal places on the inside as well. All right, that's a little bit better. Okay. Now, what does that look like here in this case? In this case here, we're going to put 0.23 here is going to be on the outside. And we're going to have 31.5 here be on the inside. Okay. So if that's the case, again, the number on the outside is 0.23. Again, I don't really like dividing by decimals, so we go ahead and make it a whole number. I like whole numbers a lot better. So let's move let's move this over here, 1 and 2. Okay, and we're going to make that, we move this over 2 decimal places, and we're going to make that outside number a 23. But of course, we have to move the same number of decimal places on the inside as well. So I need to move this 1 and 2, and I'm going to put a 0 here for those missing gaps. Again, I can put extra zeros to the right of that decimal point. 3150 is correct. That's right. But just in case, we're going to go ahead and put some extra zeros to the right of that decimal point in case if this turns out to be a decimal result, which it usually does. So there we go. Now let's go ahead and do this out here. You got the right idea there, Aiken. It's good. Everything in algebra is always about balance. Always. Okay. So let me write this out one more time. Now that we have a little more space. Okay. And now we're just going to go ahead and divide 23 straight up with this number. Let's see what we get. So 23 doesn't go into 3, but it does go into 31 one time. So 1 times 23 is 23. So 31 minus 23 is going to be 8. I'm going to bring down the 5. 23 goes into 85. Let's see, not 4 times, 3 times. 3 times. So 3 times here. 3 times 23, 69. Okay, so that's going to be 16. We're going to bring down the 0. Next one here is 23 goes into 160 actually 6 times. 7 is pretty close, but unfortunately just one off. So that's actually 6 times here. So that's going to be 138. And then you're just going to keep repeating this process here. Again, the decimal point has to line up here for division. All right. And so here we're going to get 22. You bring down the next 0. And we're going to repeat this process here. I'm going to go ahead and cheat a little bit because I don't want to spend a ton of time on this. So we're going to get a fairly long answer here, but I'm going to go out to like say 4 decimal places. You'll get 9565. All right, so you could end up with this answer here, 136.9565, and then it just depends on how many decimal places they would like you to round it to, and then there you go, you got it. That's pretty much it. So nothing too fancy there after that. You have no clue what happened after 3150. We went ahead and did long division there, Aiken. So long division is what we had to do next. So that's what I was kind of showcasing the process of doing the long division after converting it over to the 3150. Yeah, a calculator is useful here, of course. But this is how you actually find it by hand if you never need to find it by hand and don't have a calculator close by. So let's say you have let's say your phone's out, or let's say you don't have a calculator on hand. How do you do it by hand? How do you do it by hand? Well, here's the basis about how to do that. So that's just showing the process about that. One of the things that you have to be very careful about, Aiken, is it's not necessarily going to be true that you're going to have a calculator with you at all times, right? So you may end up in a situation where your phone could be out of juice, and then you're just going to have to rely on your smarts to get through a particular problem. I'm not saying that's going to happen like a lot of percent of the time, of course not. But again, if you ever do find yourself in that situation, you know, that may be that one off situation. At least you'll know what you'll be able to do. So, relying too much on electronics is also not too good. So, you got to be careful about that. Okay. So that is about, let me see here, Maricela. You asked for, let's see, sign numbers and percentages. Okay, so this is the basics about decimals here. All right, Maricela, really quick here. Does that answer stuff about decimals here? And then I'll move on here to sign numbers. Yeah, you listed three things there, so I just want to be sure that this kind of cleared up the process about how to do that. Okay, great. Now, let's move on to sign numbers here. Now, let me ask you here, Maricela, um, what part about sign numbers is really kind of getting to you? Is it the multiplication division? Is it the addition subtraction? Or is it the order of operation stuff? Which part of sign numbers are you having a bit of trouble with? Could be exponents too, by the way. We'll start with that, and then we'll look at the other things around that, of course. So, word problems and plus and add subtract. Okay. Well, let's go ahead and take a look here at both of those. I think that's perfectly fine. Let's look at the. Let me go ahead and bring up the. Just need to bring up the handout here. Okay. All right. I'm gonna go to this part right here. Those parts aren't too hard, but oh right. I don't know if there's word problems in this one per se. There are in the homework. That's true. Well, let me go over. Okay, so here's what I'll do. I know what to do here. All right, let's do it that way. All right. So here's what I'm going to do here. I'm going to go over add, subtract, and then we'll go over the word problems there, because then that'll form a basis about what we want to be doing. So that'll probably make the most sense. Okay. So let's go over adding and subtracting sign numbers here. We did talk about this recently, but let's go over some problems here with add and subtract and see how we can attack some of those problems. All right. Oh, oh. Yeah, let's do it. Time's up. Let's do this. All right. All right. So let's look at sign med. I can't spell, so you have to. Sorry about that. Spelling, not things. Yay. All right. Let's look at sign numbers here. All right. So let's talk about adding and subtracting. First and foremost here, let me throw a couple problems your way here, Maricela, and I'm going to show you how we want to attack some of these problems. First and foremost, let's say we're talking about a problem like, let's say, -5 plus -2. Okay? So really quick here for you, Maricela, just for you, what would be the answer to this problem here if I were to take -5 and add it to -2? If I were to take that, Maricela, what would I have? -5 plus -2. -7, that's right. That's correct. Now, the way we get -7 here is, again, since both numbers are negative, this is one of the cases that we talked about earlier. And this is saying, okay, if both numbers are negative, the answer by default has to be negative. So all I'm going to do here is on the side is just I'm going to ignore the negatives. I said, okay, well, it's 5 plus 2. Well, that's 7. So since I know by default that the answer is negative, and putting that together there, the answer will be -7. Okay, so that part's not too hard. Now, of course, we could add two positive numbers together. I'm not really going to go over that because pretty much you should know how to do that by now 100 times over. Now, however, I think it's to be fair to say, what happens if we get one positive number and one negative number? Let's look at that problem. All right, so let's look at, let's say, -13 plus 9. Okay, so let's say these are our two numbers here in this case. All right, okay, okay, Maricela, let's look at this carefully here. All right. So the first thing that we have to determine here is, unlike the last problem where we automatically knew it was going to be negative, we don't know what sign the final answer is going to be, but we can easily find out here. And the way we do that here is we're going to just compare the two numbers we see here, the 13 and the 9. So we say, all right, let's look at 13 and 9 here. And you say, okay, well, which one of those numbers is the bigger of the two numbers? Well, the bigger of the two numbers is 13. Now, according to the original problem here, 13 was negative. So, if the larger of the two numbers here, 13, and if that number is negative from the original problem, then our final answer from what we do know here, our final answer here is also going to be negative as a result. I know it's negative something, but I just know it's going to be negative. All right, that's the first half of the problem right there, is just determining what sign that you're going to have at the end of the day. Then all you need to do here is to go ahead and just subtract the two numbers from each other, the bigger number minus the smaller number. So all you got to do is just do straight up 13 minus 9, which is 4. And now you have two halves of the answer here. You know the final answer is negative, and when you subtract the numbers, you get 4. So your final answer here will be -4 as a result. All right? Okay, now let's have you give this a try here, Maricela. All right? So let's say I have two numbers here. Let's say I have, let's say -11 plus, let's say 19. All right, so let's take -11 plus 19. All right, Maricela, can you tell me what this answer would equal to? What would we get here with -11 plus 19? All right, you got 8. That's correct. Very good. So to showcase that, once again, we're going to take 11 and 19. All right, nice job. And again, 19 is the bigger of the two numbers. So our final answer here, I'll put it as FA here once again. Our final answer here will be positive, and we just do 19 minus 11, which is 8. So our final answer here will be positive 8. There we go. Good. All right. So that's how we do the addition problems. Now, why am I stressing very hard on the addition problems? Because they'll help you out with the subtraction problems. See, if we know how to tackle the addition problems with sign numbers, then what that means is that we can tackle subtraction for sign numbers by rewriting it in terms of addition. So for subtraction here, and let's talk about that here. So for subtraction, rewrite in terms of addition and apply the same rules. So if we want to try and simplify the process here, instead of remembering new rules, well, why don't we just go back and rewrite it and use the old rules? That just makes things 10 times easier. So for example here, if I have 3, let's say 3 minus 5, we just have to rewrite it in terms of addition. So the way we would write this is we would rewrite this as 3 plus negative 5. And then we would do it the same way we did the last two problems. We would take 3 plus negative 5 here and find our final answer. Same thing applies here as if we take, like, say, negative 11 minus negative 22. Now, if we did it this way, the negative of a negative becomes a positive. So this is the part where I say two wrongs make a right. This is definitely true. So this is equal to negative 11, the first number doesn't change, plus 22. Or a lot of people write it with just filling in the two pluses here. So you do negative 11 plus positive 22. Okay, so if that makes it helpful. And then you just apply the same rules that we did before without any trouble whatsoever. So if I rewrite it in terms of addition, then it becomes significantly easier because I just have to apply those rules and not really have to remember anything new. It's just about rewriting at the end of the day, and then that essentially makes it easier. So let's look at an example for subtraction here, right? And then we'll see exactly what we get here. So if we get subtraction here specifically, subtraction here is going to be, let's say I have negative 27 minus negative 30. Go ahead, Scrid. What kind of question you want to ask, my dude? All right, so negative 27 minus negative 30. How can we rewrite that? How can we rewrite negative 27 minus negative 30? Think about that for a moment. Because that's the first thing you need to see. How do we rewrite that before we do anything else? Can you tell me, there, Maricela? Remember, Maricela, take a look at these first two examples here. These will be fairly helpful. That's the answer here, but I need to tell. So what? All right. So 3 with a question mark tells me that you're guessing here. Now I agree with the answer here, but I want you to tell me here specifically how would you rewrite this problem here first? Because I know you could easily find an answer here. The real question is how you get there. So how can I rewrite negative 27 minus negative 30? Don't just give me the answer. Tell me the intermediary step to get to that point. Because that's the important idea that I have behind an example like this. We want to take away the question mark. We want to take away the guessing. So all right, very good. That's correct. All right. So we get negative 27 plus 30, and then you could go ahead and do the same thing we did in the last couple examples. 30 is bigger than 27. It'll be positive. You did it correctly. 30 minus 27 is positive 3, and that would be your final answer for that. But again, it's that middle step. Once you rewrite it, then you can physically see what you'll need to do next. So that's why I'm kind of harping on more of that process, more than I could say the final answer. Less guessing, more doing. All right, let me throw one more your way here, and then we'll look at some word problems there, like you asked. Let's try let's try 15 minus 29. Let's try 15 minus 29. So first, again, tell me how you would rewrite it, and then once you've rewritten it properly, tell me what you would get for your final answer. That's very loud. Yes. 15 plus 29. Be a little careful here. There are two cases that we're looking at here, Maricela, so be a little bit careful here. So we actually have two different cases here, and put this in the box here. So I'll move the box down just a little bit, actually, this way. See if I can. Yeah, let's do it this way. All right, there we go. All right, there we go. Take a look at how you rewrite that. So it's not quite 15 plus 29. Try one more time. Yep. Okay, 15 plus negative 29. That is correct. Very good. That's right. 15 plus negative 29. Good. Now, that's the correct way we can write that in addition. So now, what would that equal? If I did 15 plus negative 29, negative 14. Spot on. All right, very good. That's right. So really, as you see there, now you're a little bit more sure of your results here. Okay? But now you know exactly how you can get to that point here, again, with that intermediary step. And again, it makes problems significantly easier for subtraction, and then we're able to put that together there in that case. All right? Okay, now, you had questions about word problems there. Now, really quick here, Maricela, are there specific word problems that you want me to try from the homework? Because I know it's either the homework or something else here that you feel would be best reflected to help you with the sign numbers stuff. So there's several word problems out there, so I want to focus on the ones that you're having the most trouble with. You let me know which one of the word problems you'd like me to focus on here, and then I'll bring that up here on the my math lab stuff. Let's see, where is it here? There it is. Do you remember which meant to say cosine word problems? Do you remember what question from the homework it was, or at least like a question on a test or something like that? Because I think if we're thinking about that section there, let me see if I'm right about this. See if that was in section 110 actually. All right, let's see if this works for me. It kind of does. That's good. So it's like I know this is an estimating problem here, but maybe not that actually. It's a word problem for that. So try this again. Okay. Well, if you find a question, look, we got Tuesday as well, by the way, Maricela. So if you do find it over the weekend about what you want me to cover in terms of the word problem stuff, just make sure you have that section and those numbers in mind. I'll be happy to do that here for next class, okay? No, I totally understand that. You got one more class of which to ask me, okay? So don't worry. If you couldn't find it today, that's not a problem. We have one more class to go on Tuesday. You can ask me then. I'll be more than happy to take your question. Or ask me over the weekend. I'll be happy to answer that over email. All right? Whatever is going to be able to help you, that's what I'm here to do. Okay? So don't worry. Don't worry if you didn't answer during the stream here today. Feel free to ask me next class or over the weekend once you do find those questions. Now, I think there was one more here. Let's see. What was that other one that you said? Yes, percentages. Okay. So let's talk about percentages here. All right. This part here we can certainly talk about, as there are several important ideas about percentages that we can discuss, so we can see what we're talking about. Okay. First and foremost here, remember that for percentages, of course, we can write 30%, for example here, or again, 5.3%. Okay, we can write percentages like this. However, also with percentages here, and a lot of the times that we have to do is we have to take these percentages and we have to convert them into decimal. All right, so if we're going to convert percentages into decimal or decimals into percentages, so percents to decimals, all we have to do here, we have to move the decimal place to the left 2 spots, okay? And then all we have to do here for the other way around is just do the opposite here. Decimals to percents. You need to move the decimal place to the right 2 spots, okay? So if I look at 5.3% and I want to convert that into a decimal, all I'm going to do here is move to the left 2 spots. So I'll start with this decimal here, move it to the left 1 and 2. And so here I get our guy here of 0.053 would be our decimal equivalent here. If I have an example here for a decimal to percent, let's say I had 2.5. So let's say I had 2.5 here. 2.5 here would be, again, moving 1 and 2. So in this case here, we end up with 250%. Remember, that's entirely plausible to get something above 100%. So if we talk about 250%, there you go. All right. So just pointing that out there. Yes, that is certainly plausible. All right. Now, we did talk about a couple of other important things here in percentage problems, as there were a lot of word type of problems here. But we were able to break it down into two main things. So, first of all, the one thing that we did talk about here in percentage problems specifically is setting up those percentage problems. Now, if we talk about setting up the percentage problems here, first of all, we talked about the word of. Of means the word multiply. Okay, so in math language here, of means to multiply. We also have the word is. Is means equals. Okay, now where do we of course use this? Well, let's look at an example. An example here would be, say, what number? So what number is 31% of, let's say 71. Okay. So what number is 31% of 71? Okay. So if we want to figure this out here, we're going to have to employ one key and then basically set up our math language that we talked about from before. The one key is that we usually convert percentages into decimal. Okay. So we talk about this here. We say what number? Well, what number is a fancy way of calling that x. This is going to equal 31%. 31% can be written as 0.31. If we just take the 31, just move that over 1 and 2 spots. So that's 31%. Of means to multiply here, so multiplication, times 71. And so again, you can bit bop boop that in the calculator there. We can see what that's going to equal. All right, and so here we get our final result here of 22.01. This is, in a sense, this is what we're going to do here for literally every problem. You can also use proportions as well. We did talk about that extensively, and you'll still end up with the same answer here of 22.01, whichever way you decide to do it. So if you decide to do it that way, you would say, well, what number is 31% of 71? Well, you'd have here, in this case, x over 71. So x would be, say, the part, and 71 would be the whole, over 31 over 100. Then you can cross multiply. So here in this case, you have 71 times 31 equals 100x. So 100 times x. Again, you could figure out 71 times 31 here. Again, that's going to be 2201 equals 100x. And then we do our algebra thing here. We divide by 100 on both sides. Okay, so we do our small little algebra dealio. And so here we get x is equal to 22.01. So you get the same answer here either way. Again, both ways can net you the result that you're looking for. Okay, let's look at another problem here and another example. Okay, so here's another example. 45 is what percentage of 200? So 45 is what percentage of 200? So let's say this is another type of question that we could find here underneath percentages. Okay, now this time here, what I'd like you guys to help me with, everybody can help me with this, is tell me here how we can set up this problem here appropriately. How can we set up this problem here appropriately? What would be a good idea here for this problem? How can we set up this problem here? Can you guys write out the interpretation for this problem here? Say 45 is what percentage of 200? 200 over 45. 45 over 200. Okay. Now I need to have like the full equals and times sort of thing. So Scrid, you have the right idea here. All right. But you see how you wrote it out. This is a good point, actually. I'm kind of glad you wrote it out both ways because you kind of get confused which way things have to go. The thing is about mathematics is that you never want to guess. One of the things that we always fall into the trap of is making assumptions that things are going to work out a certain way because our brain kind of wants to think that it always works this way. But instead, what I want you to think about here is changing your perspective here a little bit. And changing your perspective is saying, okay, let's write it out and then let's see what we have in front of us. That takes the assumptions away, and at least it lets us take stock in what we have and then do the appropriate thing that we need to do after that. That's the biggest issue with math is trying to go from 0 to 60 and then just assuming things are going to work out, which it doesn't always happen. So that's why we have to be very extra careful about it. Like I said, this was kind of a harsh lesson that I had to learn on my own as well. So once I decided to slow things down a little bit and write it out, it did become significantly easier. So if I looked at a problem like this in this case, I would set it up this way. 45 is means equals what percentage, which is x, of, so that's times, 200. So we have 45 equals 200x. And now, Scrid, I'm going to agree with you here on the second answer that you have here, the 45 over 200. So here I would divide by 200 on both sides, and then I would go ahead and figure out what 45 over 200 is in this instance. And so here I get x being equal to 0.225. Now let's not forget here, this is a decimal, but we want a percentage, right? It says what percentage. So what is 0.225 as a percentage? Okay, very good. That is correct, right? If we're going to figure out what that percentage is going to be, we're going to move that decimal place over 2 spots to the right. And so here we're going to get 22.5%. So again, tackling the word problems here in percentage land will be significantly easier if we go ahead and go it piece by piece at a time. So again, magically thinking things are going to work out in a certain way is not going to be the case here. I could have easily thrown a monkey wrench into the works and be like saying, okay, you know what? Instead of 45, I could have said 300. And I know a lot of people would have put in 200 over 300, thinking that the smaller number would have to be over the larger number. When in that case, it's not true. Actually, it'd be 300 divided by 200. So that's the one thing that you have to be very careful about. It's not always small over big. It's not always big over small. Write it out how it's written and not make any assumptions that it's going to work out a certain way. Are there any questions about that? It's very dangerous to assume. If we are multiplying decimals to decimals, can we just multiply it and move the total decimal places? That's correct, Scrid, yes. You first have to, you have to first figure out how many decimal places each decimal is, and then multiply just the whole number straight up, and then move it at the end. That's right. That's exactly correct if you were to do it by hand. Yes. You don't need to line up the decimals at all, so you definitely have the right idea. Aiken, Maricela, do you guys have any questions? You guys can ask me whatever you like. Hopefully that covered percentages there in a slight nutshell. A lot of it just is basically going to do that. So, hey, you're welcome, Scrid. I'm here to help, buddy. You know how it is. You ask me questions, I do things. Question mark. Question mark. Yeah. Yeah. Maricela, any questions? Not at the moment? Okay. Well, that's fine. That is not a problem. Does anybody else have any other questions they would like to ask? Yes, Maricela, don't forget, bring some of those specialized questions to me next class, okay? For next Tuesday. I know it's our last class there, but I want to be sure I comprehensively cover everything for you before you take, before you take the dive on certain questions there. So, yeah, no problem. We're just again, just all about just comprehensively covering anything that you may want to ask. So, this is your time. Any more questions from anyone else? Any more questions? Scrid, you have a question. Aiken, you have a question. Anybody? You guys are gonna ask me whatever you like. So, all right. Stuff. All right. If there are no more questions here, I've laid it like a minute or so. If there are no more questions here, I'm not going to end the stream off here, but I'm just going to play some music here in the background because I'm going to leave this up here until 11 o'clock for the next class to come on over. All right. But if you guys have any additional questions, you can reserve that for the next class. So I will be here for that. All right. So that will. I'll be back here in roughly 15 minutes. All right. Yeah, 15 minutes. About 15 minutes. I'll be back. All right. Let me go ahead and play some music here. In the meantime, though, you guys have yourself a very wonderful weekend. We're going to see you on Tuesday. All right. We'll see you on Tuesday. All right. Everybody, kind of take care of yourself. All right. And we will see you then for the last class of the semester. All right. Take care, everybody. Have a great one. Switch this over. All right, all right, all right, everybody. Hello, hello, hello. Hey, everybody. Yeah, I had to gift you a Sabra. Of course I did. How's everybody doing here today? Oh, you signed in to say goodbye? You couldn't attend yesterday's? Hey, that's all good. That's all good, Selena. I totally understand that. Totally do. Let me switch over to my full face cam. There I am. Oh my god. Hey, everybody. How's everybody doing? How is everybody doing here today? Thank you for the love, everybody, from the hashtag channel. You guys are legends. Thank you so much, guys. Thank you so, so, so very much. I'm one off of Tiziano. Really, Idanos? Really? A one off of Tiziano. Dang. Crevette, good morning to you, my dude. Good morning. Good morning, everybody. Good morning. I hope you're all doing really, really well. I hope you're all doing really, really well. You guys are all legends. All of you are wonderful, wonderful legends. That there? So, I hope all of you are doing pretty well. It's 18. Really? It's 6 o'clock over there? Well, trust me, it's at like 11 o'clock over here. It's 11 a.m. over here. We're having a nice time. I hope you're having a nice time. I hope you're having a great time. It's 6 p.m. I hope it's 6 p.m. You get a chance to relax and chill and do the things that you have to do. 7 o'clock over there. Right on, right on. All right. Very good, very good. I'm a legend. I'm no legend. I'm just a guy, Yusuf. I'm just a guy. I appreciate it though. I appreciate it. I support my boys. I support my boys. Fact of the day from Daniel. The six living caiman species, with all of them living in Central and South America. Yes. Completely 100% agree. Selena, Selena, if you're in here, um, I see Selena, I see Sion, I see a whole bunch of guys from the hashtag channel, which all of you, I certainly thank you very much for coming on out here. You couldn't hear me? Yeah, that would probably be a problem if you couldn't hear me. But now you can hear me, so there you go. Uh, hey, so Selena, I got your message there. I want to thank you so so much there. I want to thank you so so much. Even if you do have to skip out here, this is not the last class, by the way. The last class is Tuesday, but if you were not able to come even to the last class there, first and foremost, I want to thank you for coming out to here to every stream during the course of the semester. You are amazing. So I just wanted to say that outright. It's very important. Of course, I wanted to express my gratitude to you and to everybody here who's come out through the stream throughout the course of the semester. Um, I want to express my gratitude to all of you. All of you have really put forth a lot of effort and time to help yourselves, and I'm very happy for that. So I just wanted to kind of point that out there and just let you know that that's certainly something that I definitely appreciate. Okay, if you're gonna be there Tuesday, I'll certainly see you and be there Tuesday. Okay, you have a wonderful weekend though. Okay, you take good care of yourself. All right. In the meantime, though, we got some things we gotta do. Okay, we definitely got things we gotta do. So let me go ahead and do this intro here. Let's do the intro here. Okay, let's go. Okay, let's get started today. Welcome back. Welcome back to Thursday, end of the week time today. So today we're talking about review here for anything for the homework there or upcoming tests. Or again, I talked about the final here last time. Remember, there are 100 questions here for the final. Again, that was not a typo, but I did explain my reasonings behind why there were so many questions. Of course, there's a rhyme and a reason. I didn't want to make it, and of course, naturally, I did make concessions for such a many amount of questions on a test. So again, give yourself ample time though to finish appropriately, and then make sure you get things done. Get things done. Is this the final live stream? No, we have one more final live stream here, Daniel, for next Tuesday. So next Tuesday for us here, that is officially the last day of class. So next Tuesday is going to be the final live stream here. So this class here today and the next class here on Tuesday are going to be the final two classes. Going to be today, and of course the final class here will be for next time. And what we're going to be here doing is basically doing a review here, like we're all doing here today. Now that I guess is the first question here for all of you here today is are there any questions that you guys would like me to review to kind of help you out here? I'm not sure. Are there any questions any of you have here for me that you would like me to cover briefly here, or specific examples you'd like me to cover here? Just let me know. So this is kind of like a you time here. Yeah, so the floor is yours. Any questions you guys have that you'd like me to go over? Good morning, Patricia. How are you? Maybe some more algebra? I mean, I could do a little bit more algebra. That's perfectly fine. Just to kind of get you prepped for the next class up, Patricia. Algebra by itself isn't too bad. It just takes a little getting used to. Derby County. Derby County. Thank you so much. That's very kind of you to say. I hope it's nice out in Derby County. So I hope they're doing well. I think they're in the championship, so they almost made it to the Prem last season. So Goat, thank you, Aiken. Thank you. You guys, anything you guys would like to ask me here? Again, any review questions you'd like me to go over, any type of topics you'd like me to go over. Again, anything that you'd want something to be cleared up here, feel free to ask. This is like again review time for you. So, anything you'd like me to anything you'd like me to talk about, please. You could talk about it. So LP says you don't want your own emote. Is this true? No, it's not true, actually. I would like to have my own emote, but the only time I'm going to get my own emote. So here's the thing. I was asked a while ago to get my own emote, and I declined at that time. And the reason why I declined is because my goal is to get over to England once Corona Chan is over. And only then do I want my picture taken to get my emote. So there's something to be said when you do something in person, and I would love to meet everybody out there in England first before anything else. So, I mean, I could send a picture. I'm not super photogenic, as you can clearly tell. I'm not the most photogenic person ever, but uh, let's see. You got a test coming up here. You know most things. You're stuck on a Pythagorean theorem with a right triangle, or you're stuck with Pythagorean theorem with which part with 3D Pythagorean theorem? So again, let me go over to if you're talking about Pythagorean theorem here, and we're talking about a triangle here. Pythagorean theorem by itself isn't too tough. So all the mods, VIPs, Among Us players, all the usuals, that'd be great. That'd be wonderful. I agree with that. I would love. Yep, with the triangles, perfect. Okay, let's go over an example. Okay. guys, you guys can ask me whatever you like, but I'll be happy to show up with an example. Okay, so let me go ahead and put this up here on the main screen for you, Ryan. All right. So let me put up here with the triangle. Here we go. So here's a right triangle here. Again, the Pythagorean theorem only works with right triangles. All right. So by far and away is not too bad. Hey, no problem, bro. So there are three legs to the triangle. Okay. Three legs to the triangle. There's side A, there's side B, and there's side C. Okay. So there's side A, side B, and side C. Oh, like math. Every mathematical formula. It's a little hard. So the Pythagorean theorem here, to be more specific, the Pythagorean theorem here. If I can spell. Pythagorean theorem here is fairly straightforward. Okay, so all you need to remember is that you have two legs of the triangle and you have the hypotenuse of the triangle here. And basically, it falls down to if you take the sum of the squares of the two legs of the right triangle, then that's going to equal the square of the hypotenuse. So a squared plus b squared equals c squared if you label the triangle just like so. So one of the things that you should do here, Ryan, is of course define which, well, depending on how it's of course drawn out on a picture or whatever, um, know what the two legs of the triangle are and know what the hypotenuse of the triangle is. Again, the hypotenuse here, just to let you know, is the long diagonal between the two legs. So between this leg here and this leg here, that's that long diagonal. We formally call that the hypotenuse. All right, and then with the two legs here. Now, if I were to say, let's go over something, simple here to start with. Let's put in a triangle for that. So if I were to put in a triangle here and I said, all right, let's say I had sides, let's say 3 and 4. Okay, and I said, you know what? I don't know what this side x is going to be. I don't know what the length of the hypotenuse is going to be in this triangle. Well, I need to go ahead and actually figure it out here based on what I see. So I can define A here. A can be 4 and B can be 3. And we don't know what x is because that's what we're trying to find. So here we got 4 squared plus 3 squared, all right, is equal to x squared. Okay, so that's what we're going to do here first. We're just going to plug in 4 where that needs to go. We're going to plug in 3 where that needs to go. And then we're just going to go ahead and see what x is at the end of the day. It's usually you have to work out the area of a certain side, but you have to split it into different triangles to find that side length. Okay. So this one here, just I think you know what this will work out to be. This is 16 plus 9 equals x squared. Okay, so we get 25, which is equal to x squared. Again, taking the square root of both sides. And there we go. We get 5 here as equal to x. Okay, so that part there, again, that's what it will come out to be if you're doing some algebra behind that. Now for the 3D shape, I haven't done that in a while. But let's see what we got here. I have not done that in a while, but in reality, it's not as bad as it may seem. All right, here we go. Yeah, because then you got to take that into account from the top of the. All right, let me take a look here just a second. Wow, that's loud in my face. All right. That's super loud in my face. Oh my god. For the final exam, do you need to show work? Okay, that's a very good question there. Okay, let me go ahead and answer that here really quick. The answer is no. I did put a section in the assignments tab in D2L for you to put in your work, but obviously with the amount of questions that you got, which is 100, yeah, no, obviously that's a lot, and that's way too much for me to expect you to submit a bunch of work for 100 questions. But if you do submit work there for 100 questions and your work is relevant, then you have a possibility of getting bonus points on top of the straight score that you got on the test. So you do have possibility of bonus points. Even if you get 100, I'm still going to give you bonus points above 100 for the final, should you hand in work. So it's up to you if you want to hand in work or not, Patricia. I'm not going to hold you. I'm not going to hold you to the fire that you have to, because of the sheer amount of questions. But you can snag some extra bonus points if you feel like you do so. Okay, so I'm going to leave it on. I'm going to leave it in your hands about how you want to approach. But I felt that that was a fair concession to make, based on just the amount of questions that are on the final. All right. Okay. All right. I got just the video for you here, Ryan. Let's take a good look here at this video. I'm going to bring this video up just for you. Yeah, I'm not about to leave you hanging in the cold here. When we hand in work, does it have to be on paper? You can drop it onto Google Doc. Either way, it's just easier to take a picture of hand you can put it on paper, only because, if you want to scratch out mistakes or whatnot, you can. But if you want to put it on a Google Doc, you can, and then just, send it to me through the Dropbox there, on the assignments tab. So either way, Robert, I'm not gonna criticize which way you want to go with that. So hey, it's Charlie Borley. Hmm. Oh, okay. All right. Never mind. Now I know how to do it. All right. As soon as you drew that triangle, then it became pretty easy. All right. So it's just a matter of just looking at the correct perspective. C to G, make the 90-degree cut there. Then you gotta go from A to C, which is the Pythagorean theorem with 5 and 7. And then you can find A to G without too much trouble. Okay. So, okay. I see what's going on here. So, um, let me showcase this problem here that he has up on screen, and I'll show you how I would do it here. It's not as hard as you just doing the Pythagorean theorem 2 times here on a 3D figure here, Ryan. So if you take a look here, the first thing that you have to do is draw one more triangle, all right? Because you want to find this hypotenuse that he drew here from A to C. So you want to find this hypotenuse here, which is from a right triangle from A, B, and C here, respectively. So what does that look like here? Let me go back to the paint tool here for just a moment. Okay, so what that looks like here specifically is, let me get rid of all this junk. What that looks like here specifically is it looks like this on a 2D figure. This is going to be, in his case, with the numbers that he has, this is going to be B down here. This is going to be B, this is going to be A, and this is going to be C down here. So from A to B, according to this, is 5, and from B to C, that's going to be 7. If we want to find AC, we now do the 2D Pythagorean theorem here. So in this case here, we're going to do 5 squared plus 7 squared equals C squared. And so in this case here, let's go ahead and see what we get here. We get 25 plus 49. And let's see, that's 6, that's okay, 70. Yeah. So what we're going to get here is we're going to get C, which is equal to, we're going to have C squared is equal to 74. Okay, if we add those two together based on the numbers that were given. and we take the square root of both sides. Now, 74 here would be 30, it would be 37, so that doesn't reduce down. All right, so here we're given the square root of 74 here as the length of the hypotenuse of triangle ABC. Okay, now why is that important here in this case? Well, it's because if you want this diagonal here is basically ACG. Okay, this is triangle ACG at the end of the day. And what's very convenient about ACG is that you already have A and C. So let's draw a triangle ACG here. Correct. So you need to get extra info before you put it together. That's correct, Ryan. So let's finish this problem off here based on the numbers that he has. So in this case here, we just need to have triangle ACG here. So let's put it here together. All right. So here we have A is going to be up top. Let me get the proper perspective here. Actually, we'll have C here down here, and G is going to be up top here, and A is going to be here. Okay, so that's what we have here to determine the triangle here. We already have AC. AC here was what we found here from before. AC, length AC is equal to the square root of 74. Now, according to the picture here, we also have CG. CG here is given to us as 3 centimeters. Now we just do the Pythagorean theorem one more time. So we do 3 squared plus the... Good morning, Carissa. How are you? Doing some Pythagorean theorem here. You got any questions for me, Carissa, by the way? Anything you'd like me to go over? By the way, this is AG quantity squared. So we get 9 plus 74. No, we are not learning any new material. We're effectively done. Today and Tuesday is effectively just going to be review for the material if you want to ask me questions. So here we get 83. And so we get, this is AG squared. Take the square root of both sides. And so finally, we get our final answer here of, if we want to find the length of AG, the square root of 83. Okay. Yeah, if you have any questions from any section, please let me know, and I'll be happy to do it for you. So if you want to think it over for next time, again, next class is the last class that we have here. Be sure to, again, bring any questions that you may have for next time. It's perfectly fine. Okay. All right. Any questions? Oh, where are you? Come back to me. Nope. That's the hashtag stream. Where is my thing? All right, there it is. All right. Oh, you do have one. Okay, great. Do you have any questions there, Ryan? By the way, I hope that helped. 18 times 2 is 36. Give me something harder. Okay, great. Yeah, so in fact, you're actually just, again, I think what'll help you here, Ryan, is just to visualize it. You know, like he put on the video here, like just drawing it out because you're doing the Pythagorean theorem twice, just to kind of organize your thoughts there. So I think that'll be immensely helpful when you're doing the 3D figure there, is just drawing those two triangles out. Because if you put it in a 2D perspective, it's a lot easier to work with than with a 3D perspective. So it's by far and away that's going to be the easier of the two methods for you. I think a lot of people are super visual about that, so I think that'll be beneficial for you. So it gave car sales in 1 year. You have to find the percentage of the increase of car sales in the next year over. I think that's what you're referring to there, Carissa, correct? So let's say you have car sales of 10,000 and then you sold 12,000 cars the next year. Yeah. Okay. Okay, that's fair. That's fair. Yeah, try to make it 2D. Just look at it in smaller triangles in 3D. That's correct. Right. Exactly. So you're breaking it down to more fundamental parts there. One of the nice things about mathematics is if you can break it down to the most fundamental parts, then you can start deconstructing it and then reverse engineering it into something that you can use and then put it all together at the end. All right. What if I told you there was a pattern to it? I'll show you in just a second, Goldmash. All right. By the way, the answer is 169. All right, so there you go. Okay, so let's go over the problem here. Which says, okay, let's say in 2019 we made car sales of 10,000. Let's say we had a we sold 10,000 cars. Okay, and let's say this year in 2020 we sold 14,000 cars. Okay. Okay, so this is what we sold here. We did so last year we sold 10,000, but this year we did even better. We there. My annotations, do I get them with my mouse or a drawing tablet thing? Yeah, it's just with my mouse, man. I'm a super basic dude. So I don't have a tablet or nothing. I just kind of do it by hand with the mouse and the paint tool. So yeah, nothing to. Yeah, I just want to keep things basic for me. I don't want to be like super. You know what? At first, Daniel, it was pretty tough to manage, but it got a little bit better over time. All right. Now, let's say I want to find the percent increase or the percent decrease. Okay. This works for both, by the way. Doesn't matter if your percent increase or decrease. So let's say percent increase because we sold more cars from last year to this year. So we sold more cars, sorry, this year compared to last year. So what we're going to do is we're going to follow the formula here, and it's a very easy formula. We're going to take the new value, we're going to subtract it from the original value, we'll call it original, and then we'll divide it all by the original. Okay, that's all we're essentially going to be doing here. Okay, so what's the new value here? The new value here would reflect how many cars we sold this year, right? That's the new value. So we have a new figure here of 14,000 cars that we sold for this year. Then last year was the original value. Compared to last year, our original value was 10,000 cars that we sold last year. Now all we have to do is divide by that original amount of 10,000. Now if you do this out here appropriately, again you have to do 14,000 minus 10,000 first. So you 4,000 divided by 10,000. And so if you do 4,000 divided by 10,000, you're going to get a decimal here of 0.4. Now, remember we're talking about a percentage here. Again, whether they be a percentage increase or a percentage decrease. Percentage increase means you'd have a positive percent. Percentage decrease means you have a negative percent. So, what percentage would be 0.4 in this case? What percentage is 0.4 here in this instance? There we go. All it is just takes a little getting used to. That's all. 0.4 as a percentage is like a little bit of tough time. Well, I'll wait. I know you guys got this. 0.4 as a percentage So that's a decimal, but we want to convert it into a percentage. So now I want to convert. No. 4 over 100 would be 4 over 100 is not 0.4. That's 0.04. But I want to convert 0.4 into a percent. 4%, not quite. Not quite, Derbs, not quite. You moved 1 decimal place over. Move 2 decimal places over to the right. 40%. That's right, 40%. So that's correct. So we're going to move 1 and 2 places to the right here. And so here we end up with 40% as our answer here. Not enough coffee today? Not enough coffee. Yeah, I got some coffee in the fridge. I got some. I went to the Japanese supermarket. I bought me some. Coffee here. Actually, here's an empty one. It's a nice milk coffee. The milk from Hokkaido. There you go. That's where it's at right there. Milk coffee for the win. Yeah. That's what I'm talking about. Or for $4, you can go over to the Japanese supermarket. You get some matcha green tea. Get nice 1 quart of matcha. Almost a full liter of matcha green tea. Yeah, that's what I'm talking about. Yeah. That stuff's super addictive. Oh my gosh. I can't get enough. I got like some unsweetened green tea in the fridge and stuff like that. I'm like, I need some drinks, man. I gotta actually hang on a second. Let me show you this. Let me go grab that. I'm gonna go grab that. Hang on a second. So back here. All right. Where's the Japanese supermarket? That's on the corner of Algonquin and Arlington Heights Road. So that's let me put it up on screen here for you. It's called Mitsuwa Marketplace here. So it's Mitsuwa Marketplace is what it's called here. But this is my stuff right here. I love this stuff. This stuff is like ridiculously good. So I got this is for like $1.60. So got royal milk tea. Okay, it's made with 25% milk and infused with some black tea. And this stuff here is really good. They even have like Earl Grey tea in like a can there too. So yeah, royal milk tea is really good, and this also actually, ironically enough, this also comes in this also comes with the strawberry milk as well. This company also makes strawberry milk. They also have banana milk over there as well. So banana milk's really good. So yeah, I love the specialty stuff when it comes to teas. I like milk. Can't have it in large quantities, of course, but you know what? Every once in a while, not too bad. In math tomorrow, then I have to have questions, and I have a test about fractions. Fractions, my dude. Hey, go mash fractions. Fractions aren't as bad as you make it seem out to be. It just takes a lot of getting used to, though, because okay, that's a fair question. What if it was a percent decrease? Well, let's say we did have that. Sorry, pardon me. So if it was a percentage decrease in this case, the difference would be just a small little difference here. But let's do another example here just to showcase what that is. Yeah, strawberry milk is so good. Like, I know it's so bad for me, but it's just one of those things. Is like, yeah, you know what? Um, yeah, guilty pleasures are guilty pleasures. You got to do it. Okay, so let's say, for example, here, let's say we have, I don't know, let's say the cost of let's say the cost of an item say the cost. Let's take a look at cost of item. Let's say the cost in 2019 of a particular item was $300, right? But then in 2020, the cost of that item now goes down to $120. Okay, so let's say the value of that item went down in just a year's time for whatever reason. Okay, let's find the percentage decrease here in this case, because obviously it reduced in price, but we're just finding the percentage decrease. Now again, nothing's changing in terms of how I'm going to approach things, okay? So you think that there's something different here. In fact, I'm actually not doing anything different at all. Um, it may look a little weird, but that's okay. Well, I could put that into one word. Never give children, NyQuil. Never have them become a SoundCloud rapper that sounds terrible either. So both choices are poor to begin with. I guess that's what I'll have to say. Though I like the question. It's very good. I don't think you want your mom to beat your ass, but yeah, I don't think you want to feed any babies NyQuil. That'd be pretty bad. You know why you don't want to be a SoundCloud rapper? Because maybe it's easier to be a rapper if you sign with a nice big label. Maybe you get a little more money out of it. So use the SoundCloud as your mixtape, but then after that, move your way up the ranks. I don't think anybody should give any babies NyQuil. Only children-safe medications, and only prescribed by your doctor, of course. Gotta take the prudent action, naturally. No, don't do that. I babysit. Respect. Respect there, Carissa. Yeah. No, we're here to we take care of children here properly. Okay. All right. We do new minus the original here, and we divide by the original. So notice that the formula here is exactly the same. Nothing changes. So the new value here is just the same. It's 120. So we take 120 here, subtract it from the original here, which would be 300. Yeah, that's right. You got to be careful when you're taking care of young ones. They could have potentially adverse reactions to medicines. So doctor's advice has to take precedence over anything. But please always consult your local physician to get the proper advice to how you would administer medicine to a child. All right, and then we divide it by the original here, which is 300. Okay, so this is basically how it's going to go. The new value here is still the same. Again, the new value here being in 2020, the value of that price went down. Okay, so you have 120 minus our original price, which was $300. Okay, and we divide that by the original here, which is 300. Now, you're going to get a negative number here, and that's perfectly fine. Now, if you do that here, you're going to get minus 180, and you're going to divide that by 300. And it's okay to get a negative answer here, okay? Negative answer here is okay because that represents the percentage decrease, okay, is minus something. Okay, so I'm going to do 180 divided by 300 here. Okay, and so in this case here, I have a negative divided by a positive, which is a negative, negative 0.6. And so if I do this out here as a percentage, this would be minus 60%. Or, another case, this would be a 60% decrease. Okay, so that's essentially how we actually attack these problems here. Okay, is we attack these problems this way, just doing the same exact formula. Yeah, you're going to get a negative result, but that's okay. That's exactly what you expect out of a decrease instead of an increase. Okay? Hmm. That tastes outstanding. Hey, Jawed, how are you doing, buddy? Been a little bit of time. How you been, buddy? Well, glad you could stop on by. I hope you enjoy yourself. Everybody here is always welcome at any time. Well, I'm sorry to hear that. Are you feeling a bit better, though? I hope you're back up to 100% there, my friend. Nobody likes being ill during these times, so I don't wish that on anyone, of course. But even more so now than ever. A little bit, yeah. All right, keep working your way up to 100%. You're going to feel better, hopefully, fairly soon. Came from the hashtag stream. Appreciate you, buddy. Appreciate you. Thank you very much for coming from the hashtag stream. That's very kind of you, my friend. I love everybody in the hashtag community. All of you guys. You guys are wonderful people. I just definitely am a huge supporter of the club. So, posture check. Yeah, sorry about that. Yeah, make an adjustment there. Got my lumbar pillow behind me. Yeah, being an old man. Yeah. Let me be my old man. Yes. Old man syndrome is old man syndrome. You got maths assessment tomorrow. Oh, okay. Do you have any questions there, Jawed? Actually, does anybody have any questions? Any more questions that they would like to ask me? Anybody else got any other questions you guys like to ask me? You guys can ask me whatever you like. It's perfectly fine. You're stuck on decimals. Doing multiply times plus and minus. Okay. Okay, let's go over some decimals here. None from you. Okay, that's fair. If you're stuck on decimals here, let's go ahead and just briefly cover here decimals from each perspective here. I actually did that in the first class, but I'll be more than happy to showcase it again for you. All right. So let's talk about decimals here very quickly. Where are you, buddy? There you are. All right. So, if we talk about decimals, the first thing that we'll talk about here is we'll talk about add and subtract. Okay. Okay. So if we talk about add and subtract here specifically, let's talk about the key into determining adding and subtracting here. It's okay. You got to run, Patricia? Okay, we're going to have a class on Tuesday, Patricia, so come on back then. If you have any additional questions, please come back. Again, I want to be able to answer any of those for you, okay? So we got one more class to go, even if you have no more questions there, all right? Okay, we'll see you Tuesday. You have a wonderful weekend, all right? Okay, but let's go ahead and talk about the key here for decimals, for adding and subtracting. So the key here specifically is to line up the decimals, the decimal points. Okay, that's all you have to do for adding and subtracting. So for example here, okay, let's do a simple subtraction problem here. If I have, say, 3 point, I don't know, we'll make it up here, 3.18, and let's say I'm subtracting it by 1.759, if I'm subtracting here, I want you to take a look here, Jawa, that both the decimals here have to be lined up perfectly. It doesn't matter what the numbers are to the left and what the numbers are to the right. Those decimals have to line up perfectly with each other. Okay, so that has to happen. If you see some blanks here, like you see here, just plug in a 0 here. So you're going to have 1 line up with the 7, 8 lines up with the 5, and the 0 lines up with the 9. And then you just go ahead and do adding and subtracting here. Yeah, you're definitely good to go there, Carissa. Come back on Tuesday. If you have any more additional questions, you're more than free to, again, come on back. And again, we just have one more class to go. If you need to go right now, I perfectly understand. I want to wish you the best. Have a very wonderful weekend. All right, and we'll see you on Tuesday, all right? All right. So here we're going to subtract here. So here we got like 0 and 9 here. We're going to borrow 1, so we're going to make this a 7. We're going to make that a 10. 10 minus 9 is 1. Here we have 7 minus 5. 7 minus 5 is 2. Here we have a 1 and a 7, so we're going to borrow 1 from the next column over. That'll be 2. So this becomes 11. We get 11 minus 7, which is 4. That decimal lines up exactly where it needs to be, so we'll bring that down. We get 2 minus 1, which is 1. So our final answer here is 1.421. And honestly, that's all you have to do, Java, is basically line up those decimals exactly, do your regular addition and subtraction stuff, and you're good to go. Okay, that's all you have to do for add and subtract. Just line up the decimals, though. If you don't line up the decimals, you're going to get that problem wrong 100% of the time. All right. All right. Now that's just 2 operators, though. We need to talk about some other operators, though, for multiplication and division, because those are two different things here. So let's go ahead and discuss about that. Okay. Now, discussing here about multiplication and division here specifically, let's talk first about multiplication. Where? Okay. Now let's talk about how we can figure out multiply. So the key here for multiplication is going to be we have to add up the number of decimal places between both numbers or all numbers, and move that amount of decimal places to the left after we multiply. All right. So let me make this a bit smaller here because I had this issue last time here. A bit better. Okay. So we're going to add up the number of decimal places between both numbers and move that amount of decimal places here to the left after we multiply. Now, how does that look? All right. By and large, that's the key, but of course, we need to go ahead and let's make up some numbers here. So let's start off with, let's say 1.37. And let's multiply that by, let's say 0.244. Okay, so again, I'm just making up numbers here for whatever reason. There you go. Okay, so there's no rhyme or reason why I'm picking these numbers here. Java is just like, all right, they are what they are. Okay, so in this case here, the first thing that we're going to do is before we even multiply here, we're going to count up how many decimal places that we have. Okay, for multiply, you multiply. Well, I mean, yes and no. Not exactly. We need to set it up first before we do so. Now, if you notice here, the decimal points don't need to be lined up. You don't need to have them lined up whatsoever. But what we do need to do is, if we look at the key here, we have to find out how many decimal places that there are in each number. So here, if we see 1.37. Now, if we look at the number, the amount of numbers here to the right of that decimal point is 2, which means you have 2 decimal places here in this spot. 0.244 has 3 decimal places. So I'll put DP here for decimal places. Now, at the end of the problem, we're just going to take 2 plus 3 here. At the end of the problem, 2 plus 3 is 5. We're going to move 5 decimal places to the left. Okay? That's the expectation that we are going to have at the end of the problem. So we haven't gotten to that point yet, but we are going to multiply, but we haven't gotten to the point where we're going to move 5 decimal places over to the left just yet. Okay, we're going to want that as the separate last step in the problem here. Now, what we do here, though, is basically now, how do we look at this problem if we need to do the 5 decimal places as kind of a separate step? Well, the way we want to look at it is this: let's just ignore the decimals. Let's just say they don't exist now. So if I were just to ignore the decimals and look at it as straight up whole numbers, well, this is 137. Okay, straight up 137. And then the other number here is 244. Right? That's just ignoring that the decimals there just don't exist. Right? I don't care what they are. It doesn't matter what they are. I'm just going to write it in without the decimal there. Fine. We got ourselves a winner. Now we just go through the same process here of multiplying 137 times 244 by hand. So we're going to do that here first. So I'm going to need a little bit more space here on the canvas. That here. Bada bing, bada boom. So here we have let's go ahead and do this first one here. We have 4 times 7, which is 28. We carry the 2 here. We got, put the small 2 there. We got 4 times 3, which is 12, plus 2, which is 14. And we're going to carry the 1 here. So we got 4 times 1, which is 4, plus 1, which is 5. I'm going to make a little X here. This is what I like to refer to as the cross-out method. So that just reminds us to move 1 place over to the left. All right. I'm going to do the same thing here. 4 times, for this 244, so we're going to have 4 times 7 here, which is, again, 28. Carry the 2. 4 times 3, again, 12, plus 2 is 4, 14. Carry the 1. Again, 4 times 1 is going to be 4, plus 1, which is 5. We're going to cross out 2 times here. Okay, and then here we're going to do 2. So we do 2 times 7, which is 14. And then we carry the 1 here. 2 times 3, which is 6, plus 1, which is 7. And then finally 2 times 1, which is just 2. Now all we have to do is just do our regular multiplication here. We're going to just add straight up. So the x's here represent zeros. So we have 8 and zeros. We have 8. 4 plus 8 is 12. So we put carry the 1 here. So we have 1 plus 5 is 6, plus 4 is 10, plus 4 is 14. Carry the 1. 1 plus 5 is 6, plus 7, which is 13. And then carry the 1 here. We get 3 here at the end. So far as it stands, we got 33,428 when we multiply these two numbers here together. Now, what's very important here, Jawed, is that now we're going to go ahead and apply. We're going to move 5 decimal places to the left at this stage in the game. And we're going to start all the way here on the right. So we're going to start right here on the right. And we're just going to move 5 decimal places over to the left. So we're going to go 1, 2, 3, 4, 5. So we're going to get a final answer here of 0.33428 as our final result. And you can slap on a 0 in the front there if you want. And that's going to be your final answer for that problem, for this multiplication problem. Are there any questions about that? You say you understand division, so I'll skip that then if you understand division. But I hope that now makes sense about how multiplication works, and addition, subtraction as well. So I hope that makes sense. Get now? Perfect. That's good to hear. Hey, no problem. I'm here to help. You asked a question. Would it be wrong if we didn't put the decimal? Yeah, are you talking like the in front of the 0.33? Gotta go? Okay, take care, Java. Thanks for the question. I appreciate it. Um, yeah, so you want to put that decimal in there. You want to put that decimal in there, yeah. So it would be wrong if we didn't, if we left out the decimal, of course. Because we have to account for the 5 decimal places, right? So, like, you just can't write 33,428. That's half the answer. Yeah, that's half the answer. You have to move 5 decimal places at the end to reflect the amount of decimal places that you had between both numbers. So yeah, you absolutely need to have that. So just be again, just be careful about that there. Any other questions? Ask me whatever you like, guys. It's perfectly fine. Hopefully you cleared up. Glad you asked me the question here about decimals. Definitely one of the things on your test, so definitely a very wonderful question. All right. If there are, I don't know if you guys have any more questions, but that's fine. If there are no more questions here, irrespective of that fact, I guess I'm going to leave off the stream here for today. If there's no other questions that you guys would like me to review. All right. So I'm going to end off the stream here then. If there are no more questions, I want to thank you all for coming out here today, though, for this small little review. Again, please be sure to look over any questions over the weekend. If you have any questions, feel free to email me or again, come back on Tuesday. Tuesday is going to be our last class here. Again, so be sure to bring questions with you if you want me to go over that there. Again, please start early on the final exam. I know 100 questions is a lot. So again, please start early so that way you can get going with that. Get going with that there. All right. Again, make sure you try and finish everything up here by next Thursday. That's very important. All right. All right, everybody. Thank you so much here for coming out here to the stream here again, once again here for today. I appreciate you all. I love you all. You guys are amazing. You guys are all amazing people. You guys have you guys make this stream always worth it at the end of the day. Thank you so much. And I will see you all on Tuesday. All right, everybody? All right. Have yourself a wonderful weekend. All right. Stay safe, stay healthy, and more importantly, stay sane. All right. Hopefully, good news from today. Hopefully, that vaccine will be approved today. That's what we're hoping for. All right. Take care, everybody. and we will see you all later next week. Take